Hey guys, happy Friday. I just want to run through this in case you missed class today. This is what we're doing. Your do now is there more thermal energy in a huge iceberg? This is a picture, supposed to be a huge iceberg. Or in a small cup of hot coffee? Where is there more thermal energy? Let me move myself out of the way here. You can pause the video now if you'd like and finish this right on your slides. I think there is more thermal energy in a huge iceberg or a small cup of coffee. Because why? Okay, and I'll keep going. Today I'm going to go over the learning target with you. I have a scientist of the day to share with you. I'm going to share some popcorn model ideas. I'm going to share some popcorn models with you that students made on Thursday. And then we're going to go, I'll go over with you the breakout rooms, and then I'll show you your independent work. Okay, so right now, today we are working on describing how the motion of particles changes when thermal energy is added. How do particles change when you heat them up? So real quick, I want you to make sure you're thinking about these words. Again, I'll move myself out of the way. I'll put myself up here. Here we go. Increase. When we're saying that something goes up, in academic language, we'll say it increases. If something is going down, in this case, the speed of the car is decreasing. So we're talking about speed. We're talking about speed increasing or decreasing, okay? This is our scientist of the day. His name is Dr. Hunain Massab. He passed away in 2014. You might want to stop and do a little math. How old was he when he passed away? He was born in 1926 and he died in 2014. He was Syrian. He was born in Syria and he came to the United States. He has a lot of degrees. He has a bachelor's, a master's in public health, and a PhD. The PhD he got from the University of Michigan. He's a professor of epidemiology at the University of Michigan. He made vaccines. That's what his research was about. And he actually developed something called the live attenuated influenza vaccine. And if you see this word flu in the word influenza, that's right. He actually he made a type of vaccine that you can actually stick in your nose so you don't have to get a shot about it. It's called Flu Mist, and it was declared safe by the FDA in 2003. So if you ever had a vaccine that you would take in your nose instead of a shot, it's him and his lab that created that. So I'm going to show you some popcorn models. I just want to point out a few things here. So I don't know if that's going to work. Okay, so this one I'm looking at here, I'm just going to focus on this side about what happens with the particles when the popcorn's about to pop. This one says there are more particles. When the popcorn is ready to pop, there are more particles. Okay, so if you look over here, there's 9. Here there is 13 particles. So somehow there's just more particles, and that's what made it kind of explode, the popcorn explode. It looks like they're farther away from each other as well. This one, the popcorn is ready to pop, the particles were growing and they were moving fast. So the reason the popcorn popped was the particles got bigger and they moved fast, which created the kind of explosion of the popcorn. Okay. This person is saying something similar to the last one, but they're not getting bigger. They're just moving. They're getting farther apart and moving faster. These arrows are really long, which is telling me they're moving fast. This person is telling me, I like this, they're using 2 different colors. The blue ones are the water, the liquid, I think, and the gray ones are the gas. And they're saying they're actually changing. Particles are changing from a liquid to a gas, which is really cool. I like that they wrote a lot here. It's maybe less clear here, but they wrote it, which makes it easy to understand. This last one is interesting. They're saying the particles are fast and they're colliding with each other. And they added this little thing, which I love. They added this little explosion thing. They're showing that the particles are making explosions, and that's what's causing the popcorn to burst open, to explode, to pop. Very cool. So there's 5 different ideas. Somehow they're similar, sometimes they're a little bit different. Okay, so this was from your learning yesterday. I wanted you to have a little extra hint to think about the difference between thermal and kinetic energy. Kinetic energy of a particle is how fast it's going. You can think of it as like an arrow, because we're using long arrows to show fast movement and short arrows to show slow movement, short, slow. So if you look at each of these particles as moving kind of slow, because liquid particles aren't like gases, they're not going crazy fast. And so the kinetic energy of one particle is kind of like this. It's like one arrow's length. Thermal energy of all the water, though, is adding up all of the kinetic energy of the arrows. So if you take every particle in here and you add all the arrows up, you'd get, at least the particles I can see, you get this many arrows in a row. So there's more thermal energy in the liquid than kinetic energy of one particle. Okay, so kinetic energy, speed of a particle, thermal energy, add up all those speeds for all the particles in the liquid. Okay, let's practice those ideas. So actually that's what you would do in breakout rooms. So if you're in the live class, you're coming to live class, don't do this. Is more fun to talk about it with other people. This part of the video was really just for students who missed the live class, okay? I want you to make sure we understand this. Okay, so I have solid, liquid, and gas here. Particles in which state of matter have the most kinetic energy? Let's see, the kinetic energy, going back to this thing, kinetic energy was how fast a particle is going. So particles are in which state are going the fastest? I think the particles probably in the gas have the most kinetic energy because what? You tell me. Is there more thermal energy in A or B? That means if you add up all of the arrows of the particles in A and B, in both of them there's 10 particles. I counted them up. So which one has more thermal energy? If you add up all of these here or here, right a bit below. What about in this one? Which has more thermal energy, cup A or cup B? Now, one of them isn't faster and one's slower like in the last slide. Now they all have the same speed. So is the thermal energy the same? Or is it one actually have more? You tell me cup A or cup B has more thermal energy and explain why. Okay, last of these, is there more thermal energy in a huge iceberg or a small cup of coffee? Hey, that was our do now. What do you guys think? I actually want to just go ahead and give this away for you. I think there's more thermal energy in a huge iceberg. I know you might not have agreed with me because a cup of coffee is hot and an iceberg is cold, but an iceberg is made of so many more particles. Each of those particles, even though they're cold, they do have energy. Remember, solids are vibrating in place. They have energy. And you're adding up the energy of all the trillions and trillions and trillions of particles. And the cup of coffee is tiny compared to the iceberg. And so even though each of those particles has a lot of energy, it's not the same as a huge iceberg. It's like having the cup of coffee, take a cup of coffee and stick a couple of dollar bills in it. And then take a huge mountain of nickels, of 5 cents and 10 cents and pennies, and you're putting coins in. Well, you have a mountain of pennies, like a legit Mount Rainier of pennies, versus a little cup of dollar bills. There, you have more money in a mountain of pennies. 1 penny isn't worth the same as a dollar bill. It's way, 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 way less. 1 particle of a huge iceberg has much less energy, kinetic energy, than 1 particle of hot coffee. But when you look at all of them, a mountain of pennies and an iceberg has more thermal energy. There you go. Okay, so for your independent work, you're going to first click on this interactive and go and slide this slide back and forth to look at water at different temperatures. Then you're going to take this online quiz. And you're going to be careful because when I give you online quizzes, they might end up in Synergy, or they probably will. So make sure you do it. Make sure you take your time and you do the best you can the first time. If you end up missing one and you didn't get a perfect score, do it again. Do it again. I probably won't give you the second score, but it's good to know your mistakes because this isn't the last quiz you'll take. If you take a final test, I might use the same questions and you got to make sure you know what the right answers were. Thank you guys. Have a great weekend. Make sure you get this turned in Friday so you don't have to worry about homework on the weekend, or else you're going to have homework during the weekend, okay? Bye, guys.